Good day, guys. Today we are going to be talking on Riemann integral. So let's recall from the definition of Riemann sum. You can see whereby the summation from I equals to 1 to n capital Mi delta xi, which is our Riemann upper Riemann sum, and we have our lower Riemann sum to this. Now, lower Riemann integral by definition is the supremum of the lower sum for every partition in P. So upper Riemann integral is the infimum of the upper sum for every partition in P. Do you understand? Though I will do example on this. Maybe I understand some terms there. Now let's come to Riemann stielje integral. We start by defining sum of Riemann stielje. That is Riemann stielje sum, upper and lower. Now, you know the one we've been working on, like the normal sum we've been working on, whereby we have something like this. You have our A to B, whereby we have them like this. Let's now assume that there is a function acting on our intervals that is making them larger. That is, they are monotonic increasing. You know, if they are monotonic increasing, that is an will be less than an plus 1. Let me give you the example of monotonic increasing, whereby you have, they didn't say strictly increasing, but let us say monotonic increasing. For example, they have an to be 1, an equals to 1. You know, an plus 1 will be 2. You can see is increasing. You can see 1 is less than 2. You can see it is what? Increasing. So there is a function acting on x. Let us say this is the new function g of a function acting on x that is giving us an image in real number. Now that one will now serve as our new size. You know, by the time this one gives us a value, we are going to have a new shape. That is, if it is increasing, this will be enlarged. You understand? It will be what? Enlarged. You can see it will be enlarged. Thereby, this will now serve as our new size. So instead of writing delta x, now we are going to be writing delta g of what? Xi, because this is serving as our new what? Our new size, as our new x, not size, as our new x. Now that's the work of Riemann stielje. Riemann stielje is okay. What if there's a function increasing our sizes? What if there's a function increasing our sizes? How are we going to go about it? That's where Riemann stielje integral comes in. Whereby we have this, and you know, you writing this now, delta gxi will be equals to gxi minus gxi minus 1. Do you get? So this is like the new change. Now, from the way we define our Riemann sum and all, that's how we go about defining this. Now you can see from here, the upper Riemann stielje sum is not different from this, but the only thing that is different is what? You can see the only thing that is different. Look at this, please. Look at, you can see that we have new x now, which is what? A function acting on x. That's what we change. You can see, look at the upper Riemann stielje sum of f with respect to g on AB. You can see is what? Same thing that you know, but we are now having a new x. Like this is the new x. So it instead of having change in x, it will now be change in g of x. Now for the lower too, it will be same thing. You get? Now the upper Riemann stielje integral will be the same definition here, but what is changing there is what? Instead of putting it with respect to x, now you can see this one is what? Dx. Where is the integral? You can see this one is dx. Instead of having x, now you know we are having new x to be what? G of x, a function acting on g of x. So it will be like this. You understand? Why the lower will also be the normal stuff that we know, which will be what? This is the only thing changing. Do you get the explanation? Now, when can we say our function is Riemann integrable? When if you want to say if you want to know if our function is Riemann integrable, we are going to have the upper integral the upper Riemann integral to be equal to lower Riemann integral. Lower Riemann. That is for a function to be Riemann integrable, for a function, then these conditions must be satisfied. Hereby, we have our lower being equal to the upper. Also, for a function to be Riemann stage integrable, what do you think the condition will be? If it is Riemann stage, it will be a bar b f of x. Now, what we just change is what? Our what? It will be g of x equals to a. Do you get it? So this is the normal definition. Thank you.